Okay, today we're going to talk about negative exponents. But again, this is still part of complex rational expressions. So we're not starting anything quite new, it's just a different type of problem. This kind of problem we've seen before. We did this kind of problem when we were doing our exponent rules. So we know in this case that we move the a to the negative 4 to the denominator and we make it a to the positive 4. So this is b squared over a to the 4th ab cubed. And then we know how to clean that up. What we didn't really do before is that technically what's really happening here is this is becoming 1 over a to the 4th. But when you have 1 over a to the 4th over this, then if you were to flip this over, it just ends up in the bottom with that. Now, I know that probably confuses you, but that's going to come into play here. Notice these are monomials. This is a polynomial. You cannot take this a to the negative 2 and put it down there. Okay? Because this is part of a binomial, you cannot cross into that division yet. Again, this is an implied parenthesis. We've talked about implied parentheses before. There's an implied parenthesis, which means we have to do this before we can come down here. Same way here. We have to do this before we can come up here. So you can't cross those over when it's a polynomial like that. All right, so what do we need to do instead? We need to use this idea. So yes, this is going to move to the bottom, but it's going to move to the bottom of its own fraction. So this is going to become 1 over a squared minus 1 over b squared. That's our numerator. Then in the denominator, do the same thing with these. 1 over a plus 1 over b. Once you get it to this part, this is not too bad. These are the same kind of problems that we've been doing. So again, we have this implied parenthesis. So we need to do this, and then divide. So let's walk through that real quick. So if I want to make common denominators here, this guy has an a squared, needs a b squared. So b squared, b squared. This guy has a b squared, needs an a squared, a squared, a squared. So you would get b squared minus a squared over a squared, b squared. In the denominator, we're going to do the same thing. So make common denominators again. So this guy needs a b, this guy needs an a. So we would end up with b plus a over ab. Sorry, I kind of rushed that step there. Let's talk about that. Because then this would be b over ab. This would be a over ab. When you go to add those together there, those aren't like terms, so you can't smush them together. So that's why it ends up just being b plus a over ab. Okay, now we need to do our division. So we're going to go ahead and rewrite this like we're used to seeing it. So b squared minus a squared over ab divided by b plus a. Oh, sorry, I missed some squareds. All right, over ab. So then in order to divide here, we take the reciprocal and multiply, and I'm going to go ahead and factor why I do that, because this one's a polynomial, so it needs to factor. So I would get b plus a, b minus a, over a squared b squared, times ab over b plus a. Now again, up here, you cannot cancel those. Don't get carried away. There's a minus sign there. These guys are stuck together, so we have to factor instead. All right, so now we can cancel. B plus A's cancel. These you can cancel because these are both monomials, so these are free to cancel just like this problem that we did up here. All right, so this A cancels one of those. This B cancels one of those. So what I'm left with right now is B minus A over AB. And again, this is a polynomial. Those are stuck together, so we can't cancel. So right here, we're finished. Okay, let's try another one. All right, so we have the problem 1 plus 5x to the negative first plus 6x to the negative second over x to the negative 1 plus 4x to the negative 2. All right, So what we're going to do is we're going to take these piece by piece. Now, notice in the last one, there was nothing with the A and the B. So when I went to move it to the bottom, I always just had to put a 1 on the top. But in this case, we have numbers with our variables. So let's be careful when we do this. So first of all, the 1 doesn't have a negative exponent, so it just comes down. And then we have our plus. Here, only the x gets that negative 1. So when I go to move this underneath, it's going to go underneath the 5. So this looks like this, 5 over x. Same way here, only the x has the negative exponent, so only the x goes underneath. All right, we're going to do the same thing in the denominator. This one doesn't have a number with it, so we have to put that 1 on the top. This one has the 4 there, so we put the x squared under there. I made an ugly problem. Let's fix it. Let's make this guy a minus. All right, everybody good? We made that a minus. Fix it right now. All right, here we go. Okay, so now we need to make common denominators here. Again, because we have our implied parentheses. We're going to take care of the top, going to take care of the bottom. So all 3 of these, let's make them all 3 into a common denominator so we can smush them all together. So we're going to make all 3 of these into x squareds. So that means that the first one, right now it's just over 1, so it doesn't have any x's, so it needs both of them. So we're going to multiply it by x squared, x squared. This one has 1x, so to make it x squared we only need to multiply it by 1. This one already has the x squared, so we don't need to multiply it by anything. So when we finish that, we have x squared over x squared plus 5x over x squared plus 6 over x squared. Now you might be tempted here, ooh, look, those just look like they want to cancel. But think about it, if we cancel these, what are we going to end up with? What we just started with, that would be silly. So we want to go ahead and actually add here. So we have x squared plus 5x plus 6 over x squared. Now we need to go down and do our denominator. So, oh, I made a really ugly problem. Wow. All right, well, it is what it is. Here we go. So we need to make common denominators here. So we're going to make an x squared. So this guy needs an x, x. So when we do that, we end up with x over x squared minus 4 over x squared, because that already has the whole x squared. We don't need to make a denominator there. We're going to put those together, x minus 4 over x squared. Now we're ready to divide. So let's write that as a division problem, which we're used to seeing. And then in order to divide, we factor, flip, and cancel. So when we factor this guy, that's x plus 2, x plus 3. This is a monomial, so it doesn't need to factor. Flip this guy over. This is a monomial, so it doesn't need to factor. And this doesn't factor because it's only to the first power, and there's no GCF. So right here, our x squareds can cancel, but because Mrs. Kidd screwed up the problem, the rest of this we're stuck with. So the answer to our problem is all of this jumbled mess. All right, I didn't give you a you try tonight because I just wanted to get you started, so hopefully you know what you're doing.